When people imagine the RMS Titanic, they often picture grand staircases, luxurious cabins, and massive steam engines. Please subscribe. But behind all of these features was another system working silently in the background, a vast electrical network that powered nearly every part of the ship. From lighting and communication to ventilation and machinery, Titanic depended on electricity to function as a modern vessel of its time. At the center of this system was the ship's power generation plant. Deep within the lowest sections of Titanic were powerful steam-driven generators. These machines converted mechanical energy into electricity, creating the electrical supply needed for the entire ship. The process began with steam. Boilers produced high-pressure steam by burning coal, and this steam was then directed toward engines and turbines. Some of that energy was also used to drive electrical generators. As the generators rotated, they produced electrical current, which was then sent into the ship's distribution network. This network functioned like the nervous system of Titanic. Wires and control systems carried electricity throughout the vessel, connecting power sources to lights, equipment, and essential systems across multiple decks. Considering the size of Titanic, this was a major engineering challenge. Power had to be delivered reliably to different areas while maintaining stability and control. One of the most visible uses of electricity was lighting. Titanic was illuminated by thousands of electric lights, creating an atmosphere of comfort and luxury. At a time when many places still relied heavily on gas or oil lamps, electric lighting represented modern technology and convenience. It allowed the ship's interiors to remain bright and functional day and night. But lighting was only one part of the system. Electricity also powered communication equipment, including the wireless system used to send and receive messages. Ventilation systems depended on electrical motors to circulate air through different sections of the ship. Elevators, pumps, and other mechanical devices also relied on electrical power. To manage all of this, Titanic required a carefully organized distribution system. Electrical panels and switchboards controlled how power was directed throughout the ship. Engineers monitored these systems continuously, ensuring that voltage levels remained stable and that electricity flowed where it was needed. Safety was an important consideration as well. Electrical systems had to be protected from overloads and faults. Fuses and control devices were used to isolate problems and prevent failures from spreading across the network. In a ship environment where water and metal were everywhere, maintaining electrical reliability was especially important. Another key aspect of the system was redundancy. Titanic's designers understood that critical systems needed dependable power. Multiple generators allowed the ship to continue operating, even if one unit experienced problems. This approach improved reliability and reflected the advanced engineering principles of the time. The placement of electrical equipment within the ship was also strategic. Generators and major control systems were located in protected engineering areas below deck, close to the steam supply. From there, electricity could be distributed efficiently throughout the vessel. The people responsible for operating this system worked behind the scenes. Engineers and electricians monitored gauges, adjusted controls, and responded to changing demands. Their role was essential, ensuring that the ship remained illuminated, connected, and operational throughout the voyage. From a historical perspective, Titanic's electrical network represented the growing importance of electricity in modern transportation. Ships were no longer powered only by mechanical systems. They were becoming integrated electrical environments, combining steam engineering with emerging electrical technology. Looking back, the power distribution system of the RMS Titanic shows how ambitious the ship truly was. It was designed not only to move across the ocean, but to function like a self-contained city, complete with lighting, communication, and powered systems. It also highlights how invisible systems shape everyday experiences. Passengers may have admired the bright hulls and comfortable interiors without ever thinking about the generators working below. Yet every illuminated room depended on that hidden network. More than a century later, Titanic's electrical system remains an impressive example of engineering for its era. It reflects a moment when technology was rapidly advancing and electricity was transforming the way ships operated. In the end, the power distribution system of the RMS Titanic was more than wires and generators. It was the invisible force behind the ship, the energy that connected every deck, the system that brought the vessel to life. And deep below the surface, hidden behind steel walls and machinery, it powered one of the most famous ships in history through light, motion, and the energy of a new technological age.